Hello everyone, welcome back to the channel. I hope you guys are doing all well. So we will see today's daily challenge on Leetcode and we will try to solve it together. So today's challenge is a bit interesting and as well as a difficult one to implement. Okay, so we will see the approach at first. So let's see the question. Um, Equals some grid partition 2, you are given an m cross n matrix grid of positive integers. Your task is to determine if it is possible to make either one horizontal or vertical cut on the grid such that each of the two resulting sections formed by the cut is non-empty. The sum of elements in both the sections is equal or can be made equal by discounting at most one single cell in total from either section. If a cell is discounted, the rest of the section must remain connected. Okay, return true if a partition exists, otherwise return false. A section is connected if every cell in it can be reached from any other cell by moving up, down, right or left. Okay, so the thing is, in this example, if you see, if you have solved the yesterday's problem, so I will request you to first solve yesterday's problem before going to this one. Although the yesterday's problem was a very easy one, it just told you to see whether any horizontal or vertical cut can be made so that the sum of all the elements in the both sides are equal. But in today's problem, what they are asking is that you can remove one element. Okay, you can remove one element from the grid and still the remaining sum 3 plus 1 4, still the remaining sum should be equal. As you can see in this example also, uh, 1 2 4 2 3 5 is there. If you cross out 3 and if you sum 1 plus 2 plus 4, and it's 7, 5 plus 2 is 7. Okay, now you might think that here both the sums are equal, then why isn't it is it still false? Because you see, after you remove 3, this 2 and 5 get disconnected from each other. Okay, it gets disconnected, so they should be connected. Okay, this is also another criteria which is imposed in this problem. So I hope at least the problem statement was very clear to you. And yeah, you should definitely try this problem on your own first, because then only you will understand that what are the issues that are coming up with normal implementation, and then we can then you continue to watch this video. You will end up in understanding much better. Okay, so yeah, I will first definitely request you to solve this problem on your own and then only continue watching the video. So yeah, let's see what could we do. So I hope you have already gone through yesterday's problem. So what it said is that you have a grid and you are allowed to make any horizontal cut or any vertical cut anywhere. Okay, and no matter where you are making the cut, the two portions of the grid, the sum of all elements in these two portions of the grid should be equal. Okay, so if this was x and this was sum minus x, total sum minus x, then this x should be equals to sum minus x. This was yesterday's problem and we have easily solved it using row sum and column sum, and we just calculated the prefix and sum minus prefix we did, and we just check whether they are equal or not. But this is not going to be that simple. One thing is that you might think that, hey, let's say I divide the two elements, okay, and then uh, let's say I want to see that the sum over here right now is S1. The sum over here right now is will be total minus S1. Okay. I am writing it T minus S1 will be total minus S1. Now you might think that, hey, why not remove one element from here? Okay. Why not remove one element from here? So let's say whichever is bigger. If let's say we find out that this element is greater than this element, then it is possible that I delete some cell from this greater element. Okay, so I want to check whether some value named t minus s1. See, after deletion of one particular cell, I want both the sums to be equal. Okay, so I want to delete, let's say, some value x from this. Okay, t minus s1 minus x. I want to delete some value x from this, and I want to make it to be s1. Okay, so x is nothing but t minus s1. So I hope you do realize that and t minus 2s1. So you might think that an element called x whose value is t minus s1 2s1, okay, t minus 2s1 must be present in the grid. Now again, again, as you are doing the partition, you must think that how do we realize that whether this x, see, this x can be present in left and not present in the right. Okay, how do we detect such kind of cases? So if you are thinking that I will create some map which will map me the element, okay, element of the grid to the cell ij comma grid. So this is also a good idea. Actually, you can try to do this. Yeah, you can just pause this video and try to do this approach. You will realize what are the issues. The issue will be with that I want to know which element is the, I mean, my element x is present in the left half of the grid, or is it present in the right half of the grid, or if there are any duplicate elements also at all. Okay, so that those will be the issues which will be coming up this way. So yeah, I hope you do realize. So for this one method which you can do, okay, which you can do is that you always try to cut the grid in one possible way, and you ask yourself this particular question. So if you have this grid, you always try to cut it horizontally, okay, and you always you try to remove a cell from the top. Okay, so if this is some s, okay, this is the some s, this is t minus s, so always remove. See, I want to generalize my problem, right? I want to generalize my problem. Earlier, I was thinking that hey, it can be present in any cell, or it can be present in any partition. I could have removed it from any partition, but now I'm trying to generalize that what else can I do if I try to always remove from top half, okay, top half, and cut horizontally, and cut horizontally. Now you will ask that hey, there are many types of cuts, why are you going only so specific? Okay, so just I'm taking the case when this is true. So you want to remove from the top half s minus x, that should be equal to t minus s, and in the result your x is nothing but 2 into s minus total sum. Okay, so this should be your x. Now I can tell you that hey, why not uh, you calculate the result for this. Okay, the result by cutting all possible values, okay, horizontally like this, and then you rotate the matrix by 90 degree. You rotate the matrix by 90 degree, and again you do the same thing. Again you cut in the horizontal manner, and you calculate the sum here. You remove the x from the top half only. Okay, now you must now if you are thinking that why not remove the cell from the second half, that case will be automatically handled when you further rotate the matrix. So totally you rotate the matrix 4 times. Okay, so and do the same thing. So if you try to visualize that here in the first case you have taken some x, removed some x from the top half. Okay, now in after rotating it 2 times, you are also removing x from the top half. This means that for this matrix, this is the bottom half has now become the top half, and that is why you are removing the element from this. Okay, so what you do the same thing 4 times. Okay, you just do the same thing 4 times, and you rotate the matrix. Okay, so you just calculate the all possible orientation. So in this way, you see your horizontal and vertical cut issue will also be solved. Okay, so if you want to do a horizontal or vertical cut, you will be wanting it to write the same code 2 times, right? But you do not have to do this in this method. You can just rotate the matrix 4 times, and always generalize that, always remove the top half, remove an element. Okay, so remove an element from top half and cut horizontally. Okay, always cut horizontally. So if since we are rotating the matrix, vertical cut is also taken care of. Since we are rotating the matrix, the bottom half is also taken care of. Okay, so I hope you do realize what I want to do, and this is all I just need to implement this solution. Okay, so yeah, implementation wise, this is much difficult, I can say, but let's see. Let's try to put that out from the very basic. So since I told that in my approach, I will be rotating the matrix. So let's try to write a function which will rotate a matrix by uh, 90 degree to the right, clockwise. Okay, clockwise 90 degree rotation. So rotation I can do. Uh, it will take the vector of grid only. Okay, nothing special. But what it will do is that it will return a matrix named rotated. Okay, it will return a matrix after rotating. Okay, and uh, yeah, you can have this grid dot size, grid of 0 dot size. Yeah, this thing you can do. And let's say you want to have another vector. Okay, so you want to initialize this vector of uh, vector temp. Okay, so this you can write it as, yeah, I want to have the rotated matrix, but you see after rotation the dimensions will get flipped. Okay, the row will become column and the column becomes row. So m and n which just get switched. Okay, so we will first have an n and then we will have an m. Okay, yeah. After having this, I can just go through all the elements. Right. I hope you can write this rotation constant on your own also. Okay, no issue with that. Uh, yeah. How to rotate the matrix? Just tell me a single line over here. How will I rotate the matrix? Let's see it. Okay. So yeah, you can do it in any method you want. Let me see what can I do about it. If you have this particular cell, this will automatically go after rotation. This will become this particular cell, right? Okay. And if this was I, which is m, and this was n, here it will be m and this will be n. Okay, and you might think that I can simply write it something like rotated of ji equals to grid of ij. Okay, grid of ij. You might think that why not just flip the rows and columns, but in that way it should not happen. You see here it is 0 comma 0. Okay, here it is 0 comma m minus 1. Okay, this is m minus 1. And if this was a this was a cell over here, it would have been over here. Okay, so I is changing. You see j is fixed in this hot vertical column. This j is fixed. Okay, but I is changing. So, and how much it is changing, you can subtract an I, since after it has taken, see here I was 0, since it after it has taken a non-negative value over here, you can subtract this I, as it is going backward, right? As it is increasing here, it is going backward over here, so you subtract the value of I. So from m minus 1, so m minus 1 minus I, this thing you can do. So what will be my final formula? Quickly tell it. I will request you to pause the video at many points and just try to solve it on your own also, instead of just seeing. So it would help you in understanding better. I hope you do realize this. In this way, writing in this way will just make the grid rotated. Okay. So yeah. So rotated of let's say j. ij is flipped. Okay, so j is at the first, as I saw, it is not changing, but I is changing in the order of m minus n minus 1, and that is equals to nothing but grid ij. Okay, so yeah, that is as simple as that. I have rotated this matrix successfully now. Yeah, I can proceed with my approach. Yeah, I want to do an hash define long because I'm calculating the sum, so I might get a long. So I want to do hash define ll long also. Okay, after this, I can have many things. Let's say I can have the total, which is initialized to 0. Okay, so yeah, I can have the sum. Okay, and I can have the x value also. The x value is the uh, this x which I am removing, the element which I am removing, okay, that I am calling as x in my explanation. So yeah, these things I can have it, and yeah, m and n definitely can be taken out from this grid. Yeah, m n grid of 0 dot size. Okay, yeah, I forgot this equal to. Uh, yes, after this, what can I go with? I need to have a set. Okay, so I want to see whether in the element so far I have traveled. See, I want to check whether x is present in the bottom top half of the matrix. Okay, top, not top half, wherever I am drawing this line out. Okay, so I want to check whether the elements which I have considered so far, and if I'm doing and traversal like this, okay, so I want to see that so far as I have traveled, uh, is there any x present in or not. So for that I can directly use the set. Okay, so is present, I can keep a set. So I will try to use the unordered set over here. Okay, and is present will tell me. Okay, yeah, I have it this way. And so for very first, let me just calculate this total which I have initialized to 0. So yeah, I will be using that. So I have this m int j equals to 0, j less than n, j plus plus, and total plus equals to grid ij. Okay, so yeah, for all the possible position, I just summed it out. Uh, I hope this is not much difficult. Now I want to rotate the grid 4 times and do it my thing every time. Okay, so quite obviously I will be using a for loop for that, and let's say I want to rotate it 4 times. So let's say rotation 0. I will never use this rotation variable anyways. Yeah, and so I have to rotate it 4 times. Just whatever I will do, I will write inside this for loop. I could have written a separate function also, yeah, but it's all fine. It's all fine. And every time I'm starting with, I will have my this unordered set to clear up. Okay, so is present dot clear. So I will just clear up this, and see, one thing is also there, that without removing any element also, you could draw this. See this first example in the left, without removing any element also it is possible to, if it is possible, you can return true. This is analogous to the yesterday's problem. So for that, without removing anything means you are removing 0. So you can insert, see, in this set, what are we trying to insert exactly? We will insert all these top elements. Okay, I will insert all these top elements and try to see if any x is present in this top element or not. Now x equal to 0 for not removing anything, right? So x equal to 0 must also be present in this, is present. Okay, so dot insert 0. So I hope there is no much, if not much, difficulty in this. It is easy only. So yeah, let's remove this sum and x, and let's just have it over here. So let's have a long sum over here, and yeah, n and m, we can have it from the, see, n and m is going to change. You might think that it is not changing, but it will change as the grid rotates. So every time I will just, for the safety, I will update this grid dot size. Okay, so grid of 0 dot size. Yeah, after I have this, see, one thing is there, I want to also see it connected. In this example, as you remember, if I remove 3, uh, 2 and 5 are getting disconnected. So as you can see that we need to deal some cases separately. So if I am having a matrix with only a single row and I am partitioning some element, I cannot remove any element in the between. I can only remove element at the top and at the last. Okay, and also the thing is that when I am having a grid like this, and let's say I am partitioning it in this way such that only the last row is there over here. Again, I can remove only the this element and this element. Okay, so I cannot remove any element in between, otherwise it can make the graph make the matrix disconnected. And in between, you case see any case in between, if you are removing this matrix, this is not making the graph disconnected or the matrix disconnected in any way, because you can reach this other cells from the from any cell. Okay, so yeah, I hope that is clear that why we need to take some cases separately. So yeah, for generalization, what I can do, I can write only for n. If n equals to 1, that is, if I have this nth dimension as 1 only, that is, this is the number of rows and this is the number of columns. I hope you do understand that. And if the columns is 1, we will handle it in some special manner. Okay, we'll handle it. Okay. Now you might say that, hey, m can also be 1, but again, I am rotating the matrix, right? So if m is in case turns out to be 1 or whatever, okay, uh, I don't think m and n will be 0 ever. So yeah, if m is 1 again, okay, if m is 1, what I can do, the m starts from 1 only, m and n. So if I can say that if m is 1, what can I do? I can simply rotate the grid, right? Rotation of this grid. So I can simply rotate this grid and continue with the next iteration. So in the next iteration, I will then again see that, hey, now my n is 1. Now my n is 1. So I will handle it in a special manner. Okay, in a very special manner, I will just handle this case. So yeah, what can I do? I can simply iterate through this m minus 1 dimension. Yeah, I don't want to see the last cell at all. I don't want to consider it at all. Okay, so sum plus equals to the sum which I initialized. It is plus equals to grid of I of 0. Okay, you do realize that here the second dimension is 1. Okay, so there is only one possible case of n. So if this is grid of mn, n can only be 1. Okay, so I am taking 0 here, and x, the value x, if you see, so let's have an x over here also. Okay, and x will be thing but 2 into sum minus total. Okay, I hope you do understand this. What I did told just now is that I am uh, having a column only, so I am considering the case where the number of columns is 0, right? So the matrix looks something like this, and as I have considered, I will always cut it from the top. I will always cut it from the top and see if x is present somewhere. So yeah, and for that I had also calculated what will be my formula to check. Yeah, it will be 2s minus t, if you remember this. Okay, 2s minus total. That is the thing we will use here also. And if it happens that this x is equals to 0, or this x is lying, see, when can you remove it? I told that this x cannot be present in between, but it can be present at the top and at the last. Okay, so if the x is 0, or some x is present at grid 0 0, that is at the top, or some x is present uh, at grid I0. Okay, at grid I0, then you can return true. Okay, because you have got one possibility and you can just simply return true. And otherwise, after doing all of this, you can just simply rotate the grid again. If you have not returned true, means, yeah, you can try for other orientations and you can continue. See, this was a separate case for n equals to 1. And the general case, we will handle it separately. So I guess the general case will be also very similar to this, okay, where there are multiple rows and multiple columns. So int I equals to 0, I less than n minus 1, and I plus plus for int j equals to 0, j less than n, and j plus plus. Yeah, if I try to do this and I try to do each present, I want to see I am iterating through from the top only, and I am just filling out elements. So I just insert these elements. So yeah, if I am in this grid and I have iterated this much so far, I want to fill everything in my matrix and just check whether x is present here. Okay, so I want to insert everything in this grid ij as I am traversing through this grid. Okay, and sum will be nothing but grid ij. Okay, uh, after you do this, the first thing, okay, so you are iterating the column wise. So let's say you have iterated, uh, let's say you have iterated till here. So you have iterated this first row, this second row, and iterated till here. So there is no use of this particular cell, right? You want to iterate the whole row at once only, and then see, because you are going to make a horizontal or vertical cut only. So after iterating this whole row, you have the sum with you right now, and also you know what is the value of x. Again, I had already told how to calculate the value of x. It will be what? 2 into sum minus total, right? So yeah, this is the thing. You can just write 2 into sum minus total. You get the value of x, and you just try to see whether x is present in the top half. Okay. Now again, you have more cases here that if like if you are considering on the last row on the last column, okay, then you need to handle it separately. So just check if I is equals to 0. And now if you see something like x is equals to 0, or again the x value is present in the top or bottom of the grid. So 0 0, last cell or the first cell should be present, right? So grid of 0 n minus 1, then you can return true. Okay, and in this case, if I is 0, always you would want to continue. And now you can just simply check if this x happens to be present in the grid. Okay, so if is present, contains, you can call the contains function or just do count of x greater than 0 or not. So if it contains x, okay, you simply return true. And after doing all of this, if you should definitely rotate this grid. Okay, so this bracket, before this bracket, you should rotate the grid. Rotation of grid will fetch you the rotated grid, which will be nothing but your grid. Okay, and after all of this is done, you can just simply return false, because after doing everything, if you are not able to return true anywhere, then you can just return false. Okay, I hope the implementation, although difficult, you were able to understand at least. And let's see. Okay, so we do have some wrong answers over here. So let me try to check where did I go wrong, and let's debug it together. Okay, so whatever the issue, let's quickly debug it. So let's try to see from the first. We have an m which is grid dot size, n which is grid of 0 dot size. I want to get the rotated matrix, but grid has the size of m cross n. I want n cross m. So I did it in that way, and I am iterating through the grid, but this rotated matrix will be nothing but j into j and m minus I minus 1. Yeah, I hope this rotated function is correct only. And I have this long 0, and n and m, I am having the grid n and m. Okay, and I am having this present function also, uh, but I must make this also long. Okay, uh, then I am just simply calculating the total in the grid. I guess that is also correct only, not any ambiguity over here. Now I want to rotate the matrix 4 times, and I want to see is present is clear or not over here, and is present. I want to have a value inserted. Uh, Now I have the sum and x. Sum so far, this is called nothing but the sum so far type of thing. Okay, and x, and this will be m and n. Okay, yeah. If m happens to be 1, just rotate the grid and continue. If n happens to be equals to 1, just handle it separately, right? Uh, yes. This is true, and yeah, I hope this is also correct. So after this 0 m minus 1, this is jn is present dot insert. I am inserting elements into is present, and I'm also calculating the sum so far. I have the x with me, and I'm just checking whether x is there in the cells. Looks more or less fine only to me. Then where is the error? What we changed? We just changed this is present to long. Uh, let's try to run it and see, because as of now I cannot detect any error. So uh, contains x return true, and if this I is 0, this one return true. Uh, okay, so this is 2 into sum minus total, and this is j less than grid ij, sum plus equals to grid ij. Is correct only. uh, Grid equal to rotated of grid, and you want to check whether x is nothing but okay. So yeah, you need to just check whether something like this x equal to 0, and here also. Why did I miss it in this way? I had no idea. So whatever be the case, let's see and try to run. Okay, yeah, now we have it accepted. Let's try to submit it for all the cases and try to see. Yeah, we do have a decent runtime complexity also, and I hope the approach as well as the implementation was very clear to you. If you did not understand any portion of the problem, you can simply write in the comment section. Yeah, I will explain it. That's all for this video. I will meet you in the next video. Till then, thanks a lot.